Hello friends, welcome to Unacademy. Today we are going to discuss about multi-value dependencies and how you can able to convert multi-value dependencies into single values and prove that you are going to be in fourth normal form. Fourth normal form mainly speak about multi-value dependency. So what is a multi-value dependency and how to identify that a relation or a schema is consisting of this multi-value dependency. If at all the schema consists of multi-value dependency, how to avoid them? What is the problem with multi-value dependency? We will discuss in this session. So let's crack computer science with us, top educators, quality content, great learning experience. Let's crack GATE CSE. Crack GATE and ESE with India's largest learning platform, none other than GATE Academy. Get Plus subscription and access unlimited live and recorded courses from India's topmost educators. About myself, Srinivasarao Sir, having 17 years of GATE experience in the subjects of database, computer networks, and operating system, also had industry experience as a database admin and a system admin with valuable certifications like DBA, Cisco, Red Hat Linux. Throughout my journey in the GATE academies, I taught in many premium academies, including the GATE Forum, the GATE Academy, and MADESE too. Take the subscription and get the quality content from topmost educators. If you get subscription, what will you get? You will get daily live classes, and also you will get live tests and quizzes so that your confidence can be increased, and unlimited access. You can access the recorded lectures and live lectures anytime, anywhere of the available structured courses. As far as GATE ESE concerned, there are many courses are available in CSIT stream. There are two kinds of subscription you can follow. One is a 12-month subscription. The other one is 24-month subscription. By using my referral code, you will get it 22,500 having 10% off. As usually, same is applicable on 24-month subscription too. Let's crack GATE CSE. Subscribe to our YouTube channel. Hit the bell icon for more and more updates. Now, coming to the point, what is a multi-valued dependency? When you talk about multi-value dependency, main concept of schema design when you speak, we would like to see that non-redundant schema design. So you want to get non-redundant schema design, then naturally you will get some kind of redundancy which is from FDs and some kind of redundancy which is from MEDs. So FD redundancy is somewhat reduced in 1 and reduced in 2 and reduced in 3 and completely removed in BCNF. But if you observe, still the BCNF is not completely free from redundancy because of a concept called multi-value dependency. So friends, what is the meaning of that? We will write here that BCNF redundancy is 0 as we learned and experienced from our previous classes, but this is 0 which is causing from functional dependency. But still BCNF suffers from redundancy because of MVDs. That's why when you talk about the redundancy can be generated from FDs and also can be generated from MVDs. But whatever is generated from FDs, that can be controlled in BCNF, but it cannot be controlled using the concept of multi-value dependency. So what I mean to say here is BCNF suffers from redundancy because of multi-value dependencies, because of MVDs. So who is going to control this? Therefore, this can be controlled or removed in fourth normal form. So when you are talking about the fourth normal form, you are talking about a removal of redundancy which is causing from multi-value dependencies. Friends, finally, we have to come to one destination such that whatever redundancy is generated from FDs, we can make it nullified in BCNF, but still BCNF suffers from redundancy because of a concept called multi-value dependencies. So functional dependency is denoted like this, but MVD is denoted like this. So when you have a situation like this, then it is multi-value dependency which can be removed, especially in fourth normal form, because multi-value dependency forms or generate redundancy. So let us learn what is a multi-value dependency. We understood now the other redundancy factor or cause is MVD. That MVD generates a lot of redundancy even though you are in BCNF normal form. BCNF normal form cannot do anything. That's why the BCNF is going to hand over to fourth normal form so that fourth normal form is going to avoid these multi-value dependencies. The implementation of fourth normal form and fifth normal form is not at all realistic. They are theoretical approaches. So we are trying to put it the normal form, the highest to BCNF, and the best is third normal form. Hence, we need to learn about how you could able to remove the multi-value dependencies, and you also need to learn how the multi-value dependency causes or generates redundancy. Well, friends, now we will see what is a multi-valued dependency. Multi-value dependency is a simple understanding instead of a definition from your textbooks. What is that? The shortcut to identify multi-value dependency is nothing but we already learned multi-value attributes are independent, which cannot be derived by key or a non-key or any other multi-value column. Multi-value attributes are independent. They never depends on three important things. They never depends on key. They never depends on any attribute. They never even depends on another multi-value attribute as they are independent. So this is how multi-value attributes are not depend on any other multi-value. Not only any other multi-value, it not also depends on candidate key as well as a super key as well as any attribute. It never depends on anybody else as it is individually to be treated. And next important point is that multi-value dependencies are consequences of 1NF. Why? Because when we talk about the first normal form, we understand that first normal form is free from VLAN, no multi-values. But here, once again, we are talking about multi-values, especially even though you reach to voice code normal form, still we are talking about multi-value dependency. Why? Let us see here. So what is the shortcut to identify whether there is any multi-value dependency is there or not? You can observe using this. What is that? Whenever a relation consists of more than one multi-value attribute in the schema, that's it. You will get the concept of multi-value dependency instead of functional dependency. Friends, how to prove that there are some multi-value dependencies are existed, and we also witnessed that how multi-value dependency is going to create a lot of redundancy. Now let us understand. So as far as the definition of multi-value dependency is like this, very similar to functional dependency only. It is also constrained between set of attributes. The set of attributes are nothing but set of multi-value attributes. But whereas a functional dependency is a constraint between set of normal attributes, not the multi-value attributes. So MVD is a constraint between set of multi-value attributes. It's also called as full constraint, also called as tuple generated redundancy constraint. So what is the meaning of full constraint? A constraint which express something about all attributes in your database. It's also called as tuple generated redundancy, the other name of multi-valued dependency. So you please look at this. What is that? The multi-value dependency is a full constraint as where it says that something r minus your beta. Once you observe, so now we are going to cross verify with multi-value dependency and functional dependency. Both are the factors to generate redundancy. Therefore, we will call that multi-value dependency is a tuple generated redundancy. Why? We will witness why it is called tuple generated redundancy. What is a tuple generated redundancy? By repeating one value, the other column value is also forcibly to be repeated. Hence, it is called concept of tuple generated redundancy. How come? Let us look at it next. This is another very important shortcut. Whenever you have two or more independent one is to many relationships, then there is a chance of multi-value dependency arise. Due to MVD, there is a redundancy in BCNF. This can be handled by fourth normal form. For example, let us see the example here. So R is mentioned with A, B, C, D, E, and he said that A is a primary key and C and D are multi-value attributes. Now you start thinking like this. Let me give one sample example. There is a student instance which consists of student number and a student name and a course. Now you observe, I say this is MVD, multi-value attribute. It's not MVD, it's a multi-value attribute. Now this and this is a normal single attributes only. Now I said that this is the candidate key. Therefore, what happened? When you have something like this X and course is C and C++, we come to know that it is going to be converted after conversion. After conversion, then you look at two tuples. This is what is the meaning of tuple generated redundancy. What are two tuples? S1 X C. Again, S1 tuple is repeated with a C for other pair of values. So whenever this kind of situation is there, then we can consider that it is tuple generated redundancy. Now my question is that, is there MVD? That's what my question. Is there multi-value dependency in student schema? We will say answer, not at all. This is not multi-value dependency. Why? We already learned. You want to see that multi-value dependency, there is a minimum of two multi-valued attributes. So the other name of multi-valued attributes are nothing but one is to many, two independent, one is to many relationships. So as far as this example concerned, this Are there any multi-value dependencies? We will say that no multi-value dependency in that, because we are having only one multi-valued column, and that too it is converted like this. So you got generated only S1 with this multi-value attribute, S1 with this multi-value attribute. Then how to identify the multi-value dependency? Let us look at another example. Now we are talking like this time. There is a relation R consists of A, B, C, D. A is a primary key and D is a multi-value. Please observe, friends, all of you. And B and C are single value. Now our question is there any MVD? So the answer, again we will confirm, no multi-value dependency in this. Why? You have got only one multi-value attribute. So you want to say that multi-value dependency is existed in your relation R, then the mandatory condition is like this. What is that? Now these two are multi-value attributes. Now I say this is your primary key. I say this is your single value attribute. Now you can confirm that 100%. What is that? If I am asking a question, is there any MVD, then we will confirm here that yes, because you have got minimum two multi-value attributes to confirm that there is a multi-value dependency. So let us recap our previous lecture once. What is that? If I am saying a relation like this, we know that D is a multi-value, and we confirm this question that is there any MVD? We will say no. But my second question is, what is a candidate key? So the new candidate key after conversion is a what? Your earlier primary key plus multi-value attribute. This we know. So what is your earlier primary key? Your earlier primary key is D, and your multi-value is this. Finally, your candidate key AD for the relation R. Now therefore, your new functional dependencies are AD implies B and C. This is how you can confirm. And one more functional dependency is also there. What is that? Other dependencies like earlier primary key gives you B and earlier primary key gives you C. So we know this, how to form a multi-value attribute as a candidate key with the help of your existing primary key. Okay, friends. Now you look at this. So first question, we confirm that there is a multi-value dependency, and the second question I am asking, what is a candidate key? What is a candidate key? What is a candidate key after conversion into single values? We all know how to do. What is that? Your primary key plus as many multi-value attributes you have, those many you have to write. So multi-value attributes. Finally, we confirm your primary key is A and two multi-value attributes. Therefore, your new candidate key is ACD. So what are the dependencies are there in that? That's very important. What are the dependencies are there? Let me write the dependencies here. So your candidate key as far as the previous concern is ACD, and we thought to bring your functional dependencies. Now, what is your previous candidate key is A, and previous functional dependencies A implies B, because A cannot derive C and D as they are your multi-value attributes. As we learned, multi-value attributes never depends on any other attribute, even though it is a candidate key or a super key. There is only one production is there, that is A implies B. I am bringing here A implies B. Now your new productions of your R of ABCD is a new candidate key is ACD. CD now becomes single valued attributes. Now your candidate key is ACD. Now it is implying to your other attribute like D. And one more functional dependency we want to bring from down, that is A implies B. So this is how you can able to identify the candidate key whenever you have multiple number of multi-value attributes, so that you can understand that your new candidate key is deriving your multi-valued attributes also, because as they converted into single valued attributes. Because of this conversion, is very important. Because of this conversion, what will happen? You're having the concept of what? Multi-value dependency. Again, please understand, because of this conversion, the CD is joined with your primary key to convert as a candidate key, and by taking these functional dependencies, it traces MVD. So how MVD raise, and what is the condition to identify that there is a multi-value dependency or not? You observe this definition carefully. What is multi-value dependency definition? Let R is a relation schema, alpha and beta are belongs to your relation only, and you want to prove alpha implies beta multi-valuedly. It's not a single valued, multi-valuedly. Then this is the condition. Need to cross check. So friends, don't think that when you have multiple multi-valued attributes like this, for example, I say candidate key is AB, and I am saying here DE is a multi-value attributes, and this is your single value attribute. Now we confirm there may be a chance of multi-value dependencies as your candidate key is ABDE, because your old candidate key is AB, and which is combined with DE. Now your new candidate key is ABDE. Now my question is, are there any MVDs? Any MVDs? We confirm yes. So among which attributes? Among which attributes MVD exist? Among which attribute MVD exist? We cannot say. We can confirm that there is a multi-value dependency as there are multiple number of multi-valued attributes are there, but you cannot say that among which attributes you are going to get multi-value dependency. To prove that, there is a mandatory condition to follow. What is the mandatory condition? This is the mandatory condition to identify multi-value dependency. So what is the condition, friends? Please observe. Let R is having A, B, C. Now I am writing elaborately this condition. This is the language of your Henry F. Fourth or Raghuram Krishnan or Navath textbooks. Now I am simplifying it. Let R is ABC, and you want to prove that there is a multi-value dependency between A implies B, then this condition is supposed to be satisfied. What is the condition, friends? Observe. T1 dot A is equal to T2 dot A is equal to T3 dot A is equal to T4 dot A if this is your first if condition. Please observe the same. T1 dot alpha, T2 dot alpha, T3 dot alpha, T4 dot alpha. If then you need to check two other conditions. What are the two other conditions? Tuple 3 of beta is equal to tuple 1 of beta. Tuple 4 of beta is equal to tuple 2 dot beta. If this condition is satisfied, then you have to look at other condition. What is that? Tuple 3 of r minus beta is equal to tuple 2 dot r minus beta, and tuple 4 dot r minus beta is equal to tuple 1 dot r minus beta. So very difficult to digest these definitions provided by Henry F. Court. Now let me give you and simplify like this. So when this condition is satisfied, then you need to check two other conditions to prove that there is a implies B. When I am talking A implies B, it is multi-valued dependency. So let me write the condition carefully. What is the condition? Let R of ABC, we want to say that A implies B. To prove this, what is the condition? If tuple 1 dot A is equal to tuple 2 dot A is equal to tuple 3 dot A is equal to tuple 4 dot A, then open the brace. What is the next condition? Now he is talking about B attribute only. What is that? Please look at the previous. What is that? T3 dot B is equal to T1 dot B. T3 dot B is equal to T1 dot B. And one more condition. What is that? T4 dot B is equal to T2 dot B. If this satisfies, please observe. Then please look at your definition once. T4 dot B is equal to T2 dot B. If this also satisfies, then you have to satisfy third condition. What is that? T3 dot Z is equal to T3 dot Z is equal to T2 dot Z. What is Z? I will explain, wait. And T4 dot Z is equal to T1 dot Z. If all are satisfied, then we confirm A implies B. Else A implies not possible with B. Clear? So please observe carefully. Now I will provide the data. Now you will also understand what is the Z here. Even though Z is not belongs to your R, why I chosen, you will come to know what is the meaning of Z. Here Z is nothing but this equation only I am taking R minus beta, R minus beta, R minus beta, R minus beta. That is a Z. Now let us form with data. Please understand. Now I will give data to you. Please listen. The data is like this. A, B and C. So I am providing you data A1, B1, C1. Please observe, friends. And another tuple A1, another tuple A1, another tuple A1. So I hope so you understand why I'm writing 4 times A1. As we need in the condition. What is the condition? Please observe. The condition is that A value is supposed to be equal to minimum of 4 tuples. So that's why I wrote your A value in such a way. So A value is 4 times equal. So whenever this is equal, so we know the condition. What is the condition? Tuple 1 dot A is equal to tuple 2 dot A is equal to tuple 3 dot A is equal to tuple 4 dot A. If it satisfies, then you go into inner condition. What is the inner condition? Have a look at the inner condition. Tuple 3 dot beta is equal to tuple 1 dot beta. So we will write that T3 dot B is equal to T3 dot B is equal to T1 dot B, and one more is also there, that is tuple 4 dot beta is equal to tuple 2 dot beta. So let me write the values now. I am writing equally like this. T3 is equal to T1. So tuple 1, tuple 2, tuple 3, tuple 4. Now as there is a B1, you need to write in T3 also B1. Now T4 dot beta is equal to T2 dot beta. Now I am writing something like B2 here, and you need to write B2 here also. Now we confirm the second is also correct. What is that? T3 dot B is equal to T1 dot B and T4 dot B is equal to T2 dot B. Then one more condition is there. What is that condition? That is a premier condition to us. What is that? Please look at the last condition. T3 dot Z is equal to T2 dot Z. T3 dot Z is equal to T2 dot Z, and one more is also there. T4 dot Z is equal to T1 dot Z. So therefore, you need to form the value such a way that it is going to be accepted. So we are writing T4 dot Z is equal to T1 dot Z. If all are satisfied, then we will accept. So what is that? T4 dot Z is equal to T1 dot Z. Z is nothing but your C only here. So satisfied. And I am taking a C3. When you give C3 here, C3 should come. C1, C1 is matched here. B1, B1 is matched here. B2, B2 is matched here. We confirm that A implies B successfully. So based upon the data only, you can analyze this multi-value dependency, how the A1 is generating like this. That means you understand this B and this C are multi-value attributes. That's very, very important. This B and this C are multi-value attributes. That's why A unwantedly repeating. That is the concept of what? Tuple generated redundancy. Tuple generated redundancy. Tuple itself is going to be generated redundancy. That's the tuple generated redundancy. So what do we understand? Once again, we will look at the data with one example. Let us see X, Y, Z. Z and Y are multi-value attributes. You want to prove there is a multi-value dependency between X implies B. That's why there is a mandatory condition. What is a mandatory condition? Fill the data, you will come to know. X1, 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 X1. Tuple 1, tuple 2, tuple 3, tuple 4. What about Y and Z data? If I write Y1 here, please look at your definition. If I write y1 in t1, then you have to write the same in t3 also. Therefore, t3 y1. If I write some other value, something like y4, then you have to write y4 here. Now second condition is also satisfied. T4 dot b is equal to T2 dot b. Then the third condition come here. T3 versus T2. Now if I am writing something like this, and if I am writing something like Z20, as per as your condition concern, T3 dot Z is equal to T2 dot Z. Then T4 dot Z is equal to T1 dot Z. Finally, this and this is associated, and this y4 is associated here, and this 10 and this 10 is associated here, this 20 and this 20 is associated here. Finally, we will confirm the data is exactly matched to our definition, hence it is a what? X implies to Y. Now our doubt is that why we are forming like this, why I produce data like this. There is a reason. What is the reason? Come here. Observe this example. This example is saying in such a way, teacher ID is a primary key and course name and book name are multi-value attributes. Please observe, there are some pair of values in course and pair of values in book. But teacher ID is a primary key mentioned. Therefore, you can confirm this and this are multi-value attributes. So we can confirm now there is a what? Multi-value dependency, no doubt in that, because you have more than one multi-value attribute. Now among which of the attribute the multi-value dependency is there? Now my question is that teacher implies course. Is it possible or not? You want to prove this condition, then you have to write however I wrote here. You have to write however I wrote here in this format. So this format you have to write according to condition satisfying. Then you can come to know that there is a multi-value dependency between teacher versus course. So let us form the data now. So using this example, we are trying to form a multi-valued relation table like this. Now observe. Course name and book name are multi-valued attributes. Therefore, convert them into single-valued attributes. When you are converting them into single-valued attributes, there may be a chance of what? Multi-valued dependencies like this. Then the solution here is that you have to form a new candidate key. What is a new candidate key? Your old primary key. What is your previous primary key? Teacher ID is going to form a candidate key with your multi-value attributes. We know that point. Therefore, your new candidate key is teacher ID, course name, and book name. So your candidate keys are teacher ID here, and course name here, and book name here. So now we combine all together to say that it is a candidate key. Now please observe, friends, after converting them into single values, your new candidate key is all the three attributes together. So therefore, this leads to concept of MED. Therefore, you will find what is that? Redundancy. Now, I want to tell you one another important point. The point is, whenever you have more than one is to many relationship, please observe our previous definition. Please observe this. Whenever there are two independent one is to n relationships like AB and AC, then it is a concept of multi-valued dependency. Therefore, what will happen? The same point we want to put it in our example. What is that? The teacher ID is a primary key. You cannot make it a duplicate there. Therefore, you will say that the teacher ID is going to represent how many times, friends? Only one. What about this? You have got a pair of values. Therefore, it is a what? M. Again, associating teacher ID, there are pair of values with a book. Therefore, teacher ID, for every teacher ID, you are having the concept of book name many times. So whenever you have multiple one is to many relationships in the single table, then it is a concept of multi-valued dependency. Why I wrote M here? Because the A will be associated with DB ones and C ones. B is associated with the DB ones and C ones. So how that association come? Look at this example. Please observe now. So look at the final table after mapping into single values. Now your new candidate key together, teacher, course, book, together is your candidate key. See that every of your tuple is a unique. Please observe. ADB Korth is unique. AC Navate is unique. ADB Navate is unique. AC Korth is a unique. So we are going to cross check with the 4 of its tuples. How these tuples are generated? Please come to the previous. Please observe here. So how many tuples the A is going to have mapped? Please observe. What is that? A is a mapping with DB with Navate one time. Again, A mapping with DB, Korth one time. This value with two mappings here. Again, A with C, Navate one time, Korth one time. Observe friends. This time, B, DB with Korth one time, B, C with Korth one time. So we are going to generate 6 tuples there. Why? 2 multi-value rows here, 2 multi-value pair of here. So 2 into 2, 4. And 2 multi-value pairs values here is doing with the Korth. So you will get 2. So total you will get the values like this. What is that? A DB Korth ones, A DB Navate ones. Please observe. Let me go back. A DB Korth ones, A DB Navate ones. One more. A C Navate ones, A C Korth ones. Please observe. A C Navati ones and A course name is C Korth ones. Okay, friends. Now, after mapping, you observe carefully. There is the teacher implies course question mark, and next one teacher implies book name question mark. Are there bound between the multi-value dependencies between these attributes? So we have to follow the condition. What is the condition? We already learned the condition like this. T1.a is equal to T2.a is equal to T3.a is equal to T4.a. then T3b is equal to T1b and T4b is equal to T2b. So using the same we are following. What is that? T1 dot teacher A. That means first condition is satisfied. What is our first condition? This left hand side. We are checking with the left hand side only. Teacher dot tuple 1 is equal to teacher dot tuple 2 is equal to teacher dot tuple 3 is equal to teacher id dot tuple 4 are same. When they are same, then two other conditions should be checked. What are the two other conditions? T3 dot second column is equal to T1 dot second column. Let us cross check. So second column DB is matched. Second column, the T3 dot course name is equal to T1 dot course name. T2 dot course name is equal to T4 dot course name. It is matched. When the second condition is also matched, come to the third condition. What is the third condition? This one. T3 dot other columns. Z is nothing but all other columns only. T3 dot Z is equal to T2 dot Z and T4 dot Z is equal to T1 dot Z. T3, T2, you have to check. T3, T2 is matched. Then T1 and T4 is also matched. Then we confirm it is a what? Correct. Teacher implies course. In the same way, teacher book name is also possible. This is how. So we learned three important things here. What are the three important things? What is a multi-value dependency? And how BCNF suffers from redundancy using a multi-value dependency? And third one, what is a multi-value dependency? And fourth one, how you can prove multi-value dependency using a condition and data. So if data is not matched, then you cannot say that there is a bound multi-value dependency between two set of attributes. Therefore, according to the condition, the tuple set is also supposed to be matched. So from the above, attribute level redundancy as multi-value dependency existed among teacher ID and course name, teacher ID and book name. So multi-value dependency is associated with some important rules. These are called inference rules. We also calling them as Armstrong axioms. Very important rules, very easy to understand. So you all may have a doubt here. What is the doubt? What is your Z? I mentioned there is a Z. Let me give a clarity here. Here Z is nothing but your R minus your first and second columns. That is your alpha and beta columns. That is only your Z. So as far as this concern, your A tends to B. Now what is the meaning of a Z here? ABC minus your alpha and beta combinedly add there. That's the meaning. R minus alpha and beta. Now your Z is nothing but C only. If there are any other attributes, they also will come, has to follow the same. No doubt in that. Now listen, one more example I want to provide so that you will understand what is the meaning of Z there. Let me give. There is R, B, W, X, Y. Please look at friends, all of you. I want to prove B implies W. To prove V implies W, this is your alpha and this is your beta. So what is your Z now? Your Z is nothing but R minus your alpha and beta. That is equal to, this time Z is representing as VWXY minus your alpha and beta is VW. Now your Z this time with two attributes X and Y. So let me provide the data to prove this V implies W. Okay. First one, four tuples should be matched. V1, 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 V1. So whenever first V is matched, LHS is matched, we are checking V tends to W is possible or not. I checked V only. LHS side, four tuples are matched. When they are matched, immediately you come to its beta. What is its beta? We know T3 equal to T1, T2 equal to T4. We know the definition. Please look at the definition. What is the definition? T3 dot beta is equal to T1 dot beta. T4 dot beta is equal to T2 dot beta. Same way, I am writing T3 and T1, T2 and T4. What about XY together is called as what? Z. So now, as far as Z condition, we want to understand what is a Z. If a Z is XY, as far as third column concerned, there is a statement. What is that? Your 1. This tuple, please look at the condition. What is the condition? T3 dot Z is equal to T2 dot Z. So T3 dot Z is equal to T2 dot Z. If I am writing like this, then this is supposed to be exactly same to your XY, because XY is together is called as what? Z. Now this has to repeat here. What is that? T1 dot Z is equal to your T4 dot Z. Here Z is nothing but your XY. Therefore Z means it's a, don't think that is a single column. Z is nothing but this condition only. What is that? R minus your alpha beta combinedly. By doing subtraction you will get a Z. It may be a single attribute or multiple attributes. So come to MVD inference rules. So what is MVD inference rules, friends? Observe carefully. First rule is very important, complementation. What is a complementation? Dekho. Let R of ABC let R of ABC. Now when A implies B is proved. How to prove? We land here. When A implies B is proved, then automatically others will be proved. What is that? A implies T. A implies C is also proved. Automatically it will be satisfied. Even to other columns also. If there is a one more multi-value attribute like D, then A implies D will happen. Why? Because of what? Complementation rule. What is a complementation? When X implies Y, then X implies R minus X union Y. Then it implies to all other attributes. What is R minus X union Y? R is here nothing but ABC. X union Y is nothing but AB. Then it automatically implies to others. Let me give one example here. Let R with ABCD. I say A implies B is proved. And I said that these three are multi-value attributes. And this is your primary key. Now you see, if A implies B is proved, then using complementation rule, what is that complementation rule? All other MVDs will be implied. What is that? A implies R minus X union Y. What is X union Y? Your AB only. So R is ABCD minus X union Y is nothing but A and B. Therefore, A implies CD also. So what is the meaning of that? A implies C and A implies D. So the same is applied is using complementation rule. Whenever X implies second column, then X implies to all other columns is true as long as many multi-value attributes you have. And the second one is like this, trivial. It's called as a reflexive. Whenever beta subset are equivalent to alpha or alpha union beta is equal to R, then automatically alpha tends to beta is proved. How? Let us see. There is a relation AB. I say A implies A is a trivial because your beta is a subset or equivalent to your alpha, or one more condition. What is that? Alpha union beta is equal to R. For example, I say A implies B when A union B, A and B, if I combine, if you get R, then it is coming with the help of what? Triviality nature. So two conditions for triviality. Either beta subset are equivalent to alpha, it is proved, or if LHS and RHS is equal to R, it is also what? Proved as the rules of triviality. Come to the next rule, augmentation. What is augmentation? If X implies Y and W is a superset or equivalent to Z, by augmenting W into this production, you will get XW to Y. Then I can write XW to WY reflection. I can add like this. So you will get XW implies W. One more. XWW implies Y. This is the concept of augmentation. So you will get two productions here. So transitivity, you know. What is a transitivity? If X implies Y and Y implies Z, I can write X implies to Z also. Next, replication. What is a replication? This is a very important rule. Every functional dependency is part of MVD. Therefore, I have A implies B in the sense I can write this like this, A implies B, because every FD is MVD, but reverse is not true. But reverse is not true, may or may not be true. That means A implies B may or may not be equal to A implies B. This is a very another important rule. So let us go with examples. Any doubts, you can please chat there. Now, let us start few examples to identify or to confirm multi-value dependency. He said that let AB is a candidate key, D is a multi-valued attribute. Is there any multi-value dependency? We confirm no. Why? Only D is a multi-valued attribute. You want multi-value dependency means multi-value dependency means there is a minimum requirement of two multi-valued attributes. Otherwise, it's not possible. Because when you talk about the tuple generated redundancy, the tuple generated redundancy depends on multi-valued attributes. Come to next question. And what is your candidate key here? Your new candidate key. Your new candidate key here is your existing candidate key plus multi-value attribute. So ABD. So what is your functional dependency? As there are no multi-value dependencies, ABD implies C. One more functional dependency is there from here we want to bring. What is that? Existing primary key implies C value. But existing primary key doesn't imply D, as D is a multi-value. So your previous functional dependency, I am writing here that AB implies C, but here don't write that AB also implies D. This is wrong because D is a multi-valued attribute. So come to next example. Now we are saying AB is a candidate key. This time we are running exactly correct. CD is a multi-value attribute. Now the solution I am giving you, your candidate key before is AB and the dependencies are AB implies AB only because C and D are together multi-value attribute. So candidate key cannot derive them. That's why I have written AB implies AB. Now after conversion, we understand what is that? A new candidate key we got. What is your new candidate key? Your old candidate key along with your CD. Now your new candidate key is A, B, C, D. Completely it is candidate key only. Now naturally, are there any multi-value dependencies? Yes. What are the multi-value dependencies you will get? You will get AB implies C from here to here, and one more AB implies D using a complementation rule. Whenever you satisfy with the first attribute, then it automatically satisfies with other attributes. That is the specialty of this. Now come here. So AB is a candidate key, CD is a multi-value. What is a new candidate key? We will write very simple this is. That is, your candidate key is AB with CD. So there is a multi-value dependency. AB implies C and AB implies D using the concept of what? Complementation rule. Next, how many number of rows are mapped into R after conversion into multi-values? This is a very simple. How many number of rows are required after mapping into your multi-values? So it's very simple. There are two values in Y and there are two values in Z. So 2 into 2 is equal to 4. For every 4, x is going to be repeated. So what is the answer? x1, y1, z1. Again, x1, again, x1, again, x1, y1 should come. x1, y1, this time z2. Next x1, y2, z1 or z2. x1, y2, z1. So exactly what has happened? This value is matched. T3 is equal to T1 is matched. T2 is equal to T4 is matched. Z1 is equal to Z4 is matched. Z2 is equal to Z3 is matched. Bus X implies Y as well as X implies Z2. Now, this is a good example. Suppose we have ABC with a multi-value dependency A implies B. So the first tuple is A, B1, C1 in A and B and C attributes. What are the other tuples required to prove A implies B? What are the other tuples required to imply A implies B? We know, very simple. We know that is what? A should come here 4 times. Tuple 3 of B is equal to tuple 1. Tuple 2 of this is nothing but this. And C value, C here, and some other value you can write like this. So any pair of values you take, see that this condition is supposed to be matched. So as far as that, if you choose the option, I have taken ABC here, and the first tuple is mentioned A, B1 and C1. So now I am taking like this. For example, if I am taking option A, what will happen? A and A and A. I have written this. Next B1, B1, B2. And next C2, C3, C1. So is it correct or not? You need to check. If not correct, according to our condition, then you have to go to next option B and see that whether it is satisfying or not. Then go to next. Exactly like this it's supposed to match B and C values in order to prove A implies B. So this is one of our GATE question on multi-valued dependency. So how come it is? I already told you A implies B is not equal to A implies B. This is MVD, this is FD, this is false. That's why it's false. What about next? Next I said, what is that? Replication rule. Please understand friends. What is the replication rule? Every FD is MVD. Every FD is MVD. Therefore, A implies B and A implies C. Nothing but A implies BC. I can write like MVD because every FD is a what? MVD. Therefore, it is a true. And next one, A implies BC. I cannot write like this because MVD cannot be what? Functional dependency. But next one you can write like this. What is that? A implies BC. I am writing into one FD, no problem. I am writing into one MVD, no problem. Because every FD is a FD and every FD is MVD. Every FD is FD and every FD is MVD. So using this rule, we confirm that the fourth is also correct. So what is a fourth normal form? The fourth normal form is trying to main 4NF responsibility is that 4NF is supposed to be in BCNF and see that no multi-value dependencies. This is the rule. Because BCNF suffers from redundancy because of multi-value dependencies. These multi-value dependencies are coming from multi-valued attributes. So what the 4NF is saying, every 4NF is into BCNF without having multi-value dependencies. Therefore, it is concerned with multi-value dependency. No other normal form deals with multi-value dependency except BCNF, fourth normal form. So a table is in a fourth normal form with a multi-value dependency X implies Y, where X is either candidate key or super key. What's the meaning of that? Let me give conclusion here. It's very simple to identify fourth normal form. How to identify fourth normal form easily? Look at friends. I say there is a R, ABC. This is a primary key. Therefore, this is a one relationship. This and this multi-value attribute. Multi-value attribute have pair of values. So this is going to repeat for every of this B value, and one more. For every of this is going to repeat for this one more time. Therefore, there is a 1:2 many relationship between A and C. There is a 1:2 M relationship between A and B. This is between A and B. This is between A and C. Whenever you have two independent 1:2 M relationship, then there is a concept of multi-value dependency. So to avoid multi-value dependency, what you supposed to do? Break R into 1:2 many relation. Bus. This is only the secret in fourth normal form. So how to prove? Look at carefully. There is a R of ABC, primary key, multi-value attribute, this is M, this is M time you can repeat, this is a one time you can repeat. Therefore, A1 is coming for B1 and A1 is also coming for B2 and A1 is also coming for B1 and A1 is also coming for B2. If you have B1, B2 values here, C1, C2 value here, A1 value here. Anyhow, you are repeating this, you are also repeating others, C1 and C2, C1 and C2. What is the meaning? Because of this pair of value, you are repeating other column as well as primary key. Because of the second pair of value, you are repeating other column as well as A value. That's why we confirm B is repeating A value and we confirm C is also repeating A value. So to avoid MVD, what I said, your R is with ABC suffering from A implies B and A implies C, break it. How to break? R1 with only AB and R2 with only AC bus. Now you got our original single valued conversion. What is that? A1, B1, A1, B2. You know how to convert. If I am giving only AB together, you know how to convert it. In the same way, this time AB together is a candidate key because I am splitting all multi-value attributes into single sets so that it is going to merge with your primary key. Now here also you have AC, and instead of raising 4 times, I am raising only A1 with C1 and A1 with C2. See, they are unique values. Observe carefully. This is unique value. This is unique value. This is unique value. This is unique value. AC is a candidate key here. Bus. So whenever you have this kind of a situation, you are splitting your 1:many relationship into as like this. So instead of having 1m and 1m, so I am splitting into two parts. Now I got together 1:m becomes like this, 1:m becomes like this. So we got no multi-value dependencies except functional dependency. What is your functional dependency in the R1 and R2? Your functional dependency in the R1, R2, very simple. As AB is a key which implying AB, as AC is a key which implying AC. This is how to convert your MVDs into fourth normal form. Let us take one more example. I am saying X, Y, Z. This is our last example. Observe carefully. Multi-value attribute. We have pair of values here. We have pair of values here. Even you can write Z3 also, no problem. You can write Y3 also. I have got X1. Now we confirm your new candidate key. What is that? X, Y, Z together. Now you will get how many rows? Total 9 rows. X1, 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 and X1 and X1 and X1 and X1. Because you have to write the other combination also. Y1 with Z1, Y1 with Z2, Y1 with Z3. Again Y2 with Z1, Y2 with Z2, and Y2 with Z3, and 3 other. Because 3 pair of values multiplied with 3 pair of values, you will get those many rows with X1. So what to do? We prove that X implies Y, and also we prove that X implies Z. Now we are converting into 4NF. This is acceptable in BCNF, but this is acceptable in BCNF. This is acceptable in BCNF, but in fourth normal form, it is not acceptable. So how it converts? Simply X implies Y and simply X implies Z. I am splitting multi-values into only one table. One multi-value, its primary key. One multi-value, its primary key. So what are your tuples? Now you can write that XY is your candidate key. So you can write X1 with Y1 combination, X1 Y2 combination, X1 Y3 combination. Bus. Now you observe these rows are unique. X1 Y1 unique, X1 Y2 unique, X1 Y3 unique. So here also same X1, Z1, Z2, Z3, X1, X1. So here your candidate key is what? XZ. There are no multi-value dependencies in this. So we have converted your MVD. Please observe. You have converted your MVD into FD. You have converted MVD into. That's it, friends. So fourth normal form is a very unrealistic. Why unrealistic? Because of many permutations and combinations. So we all feel that BCNF is one of the highest normal form for any schema design, but very tough to implement BCNF. So we are restricted to third normal form. But still you have multi-value dependencies in voice code normal form. You can still reduce or normalize them into fourth normal form by converting your MVDs into FDs concept. So fourth normal form is saying strictly no multi-values allowed. So four normal form is saying that no multi-value dependencies allowed, provided that you're supposed to be into what? BCNF concept. So how are you eliminating them? Very simple. Alpha implies beta, and alpha implies some other like C. As this is MVD, we try to put it into alpha implies beta decomposition. I am doing here. I am doing another decomposition, that is alpha implies C. So instead of having merging all multi-valued attributes into a single table, better you split them. This splitting is the concept of what? Fourth normal form decomposition. What the fourth normal form is saying, instead of keeping all these things into a single table, better you decompose them so that your MVD becomes FD, your MVD becomes FD. That is the concept of fourth normal. Okay, friends, stay tuned to us. Please use my referral code for upcoming lectures and to take the subscription. Thank you very much.